CNC Pod with Jatinder.
All right, good morning. I think we're live now, Ben. So, hey everyone, it's the third podcast, and I think everyone's been enjoying the podcast till now. Thanks for your great feedback. And today we've picked up a hot topic, homing. So many people have been talking about this. And I need to first thank Ben. He's not feeling well. He's got a flu, but he's still joining us. So thank you, Ben, for coming in, mate.
Thanks for having me.
How are you doing? How are you feeling now?
I'm getting better, actually. I've had a busy couple of weeks. Just been moving my home and workshop interstate. So
And being sick.
Been sick. I think run down a bit from all the extra work, but no, feeling well, thanks, and glad to be here.
Great. All right, cool. So regarding the homing, Ben, first of all, let's start off with the whole concept of homing. Why do we need homing? What's the benefit of homing, and if we don't have a homing option? Because I think you also must have a lot of clients who are running the machines without actually homing them. They'll just power on.
Yeah.
Got a reference point.
Yeah, quite a while ago, when we were still having a lot of issues with interference with limit switches, we did have a lot of people, and myself, I ran a machine without a homing cycle for probably 6 to 12 months. And so you don't actually need homing, but it is great.
Right.
Yeah.
Okay.
If you ever need to restart a job and you don't have homing, it's borderline impossible unless you can do a probing cycle, which if you're not set up for homing, you're probably not set up for probing either.
Yeah. Yeah. And also, things such as if you have tool holders, for example, and you've pre-calibrated your tools, then you can't even, use your tool table every time. You have to kind of find the reference for that tool, and only then you can go and home the machine. Use the machine. All right. So basically, let's start off by first with the concept of what homing is, how homing works, and the video it's not switching on its own, so I have to manually do it. It's a bit annoying. If I can find that option, I don't know. Okay. Basically, I was saying let's start off with how the concept of homing, then how it works and whatnot. So from the machine point of view, when you actually power up your controller, your axis of the machine can be sitting at any given position. When you power up your controller, it does not know the exact location. And to be able to reference itself, we actually move the axis to a known point, and that known point is called the home position. The homing position can be on either side. So, if your axis has a travel of 500 millimeters, it can be either you home to let's say the zero location, or 500 millimeters. It just does not matter. It depends on how you set up things, maybe the design of your machine. But it's one known point where you come to every time you do a homing cycle. So the way it works is on that side. So as an example, let's say we put a homing switch or a sensor on X0 location, and you power up your machine. It's sitting on at a random location that you don't know. Next, we run a homing cycle. With the homing cycle, everything's set up in the controller, and you start the cycle, and basically the controller moves the axis towards that location of your sensor or the switch until it's pressed or triggered. So as soon as you press that, it stops, and then it knows that it's that given position. So in this case, it's X0. So it says, okay, I'm on X0 position. And from that point, you can go back to your location. So if you were running an earlier job at, let's say, X100 location, so from this X0 to X100, you can always come back. So you have a reference point. Simply not having this reference point every time you start your machine, that X100 is going to change for you, depending on where your X's are. So,
and I'm interested to know, maybe we can ask some of the guys watching here where they're homing to. Convention on a router table was always to the back right, and I've read about it a few times but can't actually recall why. I know it's convenient for me to use the back right as my home position because it leaves the gantry clear for me to load stock in the machine.
Right.
But I don't think that's the reason why convention says to use the back right. And I believe a lot of people aren't any longer. They're using the front left of the machine. But yeah, interested to know from anyone listening, if you want to bash into the comments, where do you home to and why? Because it'd be interesting to know.
No, it's good data in that sense, and from the actual workings of it, it does not matter. Just to let people know, because we get these questions as to some people say, hey, do we have to home to X0, for example, and we always say no, it can be any reference point. Whatever is easy for you to wire, or depending on the design of the machine, maybe it's easier to mount the sensor on one location, or as you said, maybe just loading the job. Another thing to keep in mind on that is that homing position. For example, if you home your machine, let's say, Ben, as you were saying, towards the back of your axis, and if you've defined that location to be your Y 1000 millimeters or 2000, depending, every time there's a G28 command, the machine will go back to that position.
Yeah, because that's the main pain about homing to the back right, is that there's a little bit of time. I remove all of those go to zero positions from my G code because they do take some time. And that's the main problem, is that I often do work in the front of the machine, yet I'm homing to the back. So there's that time of moving from home. And I think some CNC machines have a second set of homing sensors that are like a proximity that allow the machine to home at a rapid feed rate until it sees that switch and slow down. That'd be a great one for you to add to the Masso chat. That'd help me out.
Yeah.
There's some more work for you.
We have been talking about that a bit. It can be fairly easily done, given that we have so many inputs sitting free on the Masso, and you can have a few more inputs for that. For sure. So basically with G28, what I was trying to say otherwise is definitely takes time. You're saying, especially on a big entry type of setup. When you're making a G codes, there's an option in, for example, Fusion it's going to add G28. You have to disable it depending on what kind of post you're using. But just to clarify to people, because it adds to a bit of confusion, saying that if you home to, for example, X500, that's the other side of your axis, sometimes you think to believe that if you give G28, it's going to go to X0, zero being the home position. But that's not the case. It's where you set up your homing sensors is your home position. So if you give G28, in this case, it will go to X500 if your sensor was on 500. So, just for people to keep in mind, just in case if, depending on the job, they want to actually come to XYZ0, for example, every time they finish a job. So I would say manually make sure you add something like G53 and then put in X0, Y0. So, you're on that side of the axis. So something to check in your G code. Anyways, every time when you're running your G code, it's a good idea, do a dry run it slow, those things. And when you're designing your part, and you're visually looking at maybe in Fusion, you know how the cycles are going to be, how the tool's going to move. But something like G28, it's a small code. You just have G28, and you're so focused on the job that how it's going to do maybe a circular pocket, whatever you're machining, that you overlook G28, and you start your machine, and maybe you were just very near to the job, and you're like, yeah, it's going to start cutting straight away. All of a sudden, the machine's running away from you at full speed and towards the homing location. So that is something, it's not like exact homing topic, but it's related. And that's what we're going to try to cover today, that a lot of things, they are kind of around homing that you need to keep a watch.
And that I have my bigger format machine rapiding at between 40 and 60 meters a minute. So when you get a G28 there and it's booging towards home at 60 meters a minute, it's also a little bit stressful, even though I know that Masso always pulls it up just in time, but still it's a little bit daunting. Another reason why I don't use it a lot. But one of our first points was why do you need homing? I don't know if we cover that off completely. And
true. I think I jumped straight into the how it works. Yeah. So yeah, if you want to go ahead with that.
Well, I use homing all the time now because I'm only using Massos on my own machines and it requires homing. Well, I've set it up to require homing, but generally I would home or not home depending on the type of job I was doing. If it was something with a cheap material, a job that I'd run before, or a job that I didn't think for any reason would need restarting, I quite often didn't home the machine. I'd just set X, Y, Z 0 at an arbitrary point over my stock and run the job. But I did find that any job that there was even the slightest concern of needing to restart, if I expected some issues or I hadn't run that G code before, or it was a 3D job that was going to run for hours and I may need to break for lunch and return to the machine, basically, if you didn't home the machine and set an offset from home for your job, then chances of restarting that job after a broken tool or a trip to the bathroom or a power out, the chances of restarting it easily are pretty much none. And that's really why I think you need to home. Other than the fact that without homing, you don't have soft limits, and they are really handy as well. So can you think of any other reasons why homing is super important?
Yeah, no, it's definitely those points. And another point, I want to just mention here, and we had that talk, with one of the clients who was rehoming his machine every time he was cutting something. So that's also kind of maybe we need to clarify this, that you only need to home your machine in certain conditions. For example, when you power up, because you don't know the location of your axis, or you hit something on your machine, or your stepper drives have an issue, your stepper motors have an issue, you have a mechanical issue where you think that you might have lost a step, and you might have, by losing that step, you lose the reference of your position. So that is where you need to rehome the machine. So, if there was a mechanical issue, fix it, and then rehome the machine. So
after an e-stop, usually.
After an e-stop is a good one. Yeah, exactly.
And they're really the only times to home. I have recently had a customer that was doing a job, and he kept losing 1/4 of a mil, 1/10 of a mil. He could see it in the steps in the job, and we were talking about his method, and it turned out it was homing between each tool change. And if he was using some optic interference switches that are really, really accurate, he might have got away with that. But he was using the lever limit switches, and there's not enough repeatability in that sort of switch to be homing mid-job. And I'd never considered homing between mid-job, and it took a while for me to ask the question and realize that it was homing between each tool change. And so that's definitely unnecessary and potentially ruin the job unless you're using a really nice switch and you're homing at a speed as well that allows for repeatable homing.
Yeah, exactly. And that is why we need to really understand what homing is. It's not that you rehome and it's going to do something magical. In fact, as you just said, with an example of a mechanical switch, because most of the people are actually running those mechanical switches. So that's what happens, and we're going to cover that in the topic. We have that in the list down the track about how do you select your switches or sensors. But that's a great point. So if your machine is running fine, you're machining, you didn't lose a step, you didn't hit anything while machining, then don't home. While it's powered up, don't home. It's pretty much every time you power up your machine that you need to home the machine. And that is why for people who are actually using the Masso, and I've seen some clients, they haven't still set up this, even if they have homing, in the general settings, in the homing settings in Masso, there's an option that you tick in, and it enables an alarm when you power up. So when you power up your controller, it's going to flash an alarm and ask you to home the machine. You can still jog the machine around if you need to get away from something, but then it won't let you run anything. And it's basically telling you that, hey, I haven't been homed. Please home me before you start. So people don't mess this up. I actually had a old client, and he was running a production job. At that time, we didn't have this option. So he would remember to home the machine, but the other guy who was actually running production for him, he would forget at times. He would come after lunch and cycle start, and bang, it's gone. So that's where we said, okay, we need this option, and it comes in really handy. It just, you're busy, you're thinking about your business, what you have to cut, you're focusing, and then you can forget that you have to home the machine. So please take that option in. Every time you switch on, it's going to tell you to home the machine, and you can go from there.
I noticed a few comments here in the on the YouTube. A
Right.
lot of people are using the front left. Nobody's had a good reason why yet. I think just like me, that's the first thing they did, so they've continued. But some 3 or 4 people saying, yeah, front left.
Right. Okay.
Interesting.
Yeah, cool. And yeah, so it can be any location, whatever suits you as per your machine, does not matter. It's just a reference point. That's what we have to understand. So yeah, Ben, we were saying about when do you need homing. So that's the first thing, that you need to find a reference point. And now let's go a bit more by saying, okay, you have a reference point. How can it help? First of all, if you have a production job where you have a jig that you're just putting material in, then definitely once you have that jig, you've set up to your work offset screen in the memory, and you have the location logged in. You're running a production job, so it's a must. If you need to restart your controller again the next day, you need to come to the exact reference point. And if you don't have homing, imagine every time you start your machine, you have to, as you say, you have to probe it. You have to dial in, spend all that time. And if you have homing, simply home the machine. 20 seconds later, you can start your cycle, straight away. So, it's great for, fixtures, production jobs. It's a must, it's not even, let's say, you can get away, but it's just too time consuming. The next one is the tools themselves. Now, with the tools, obviously, there are different options for calibrating the height of the tools. For example, we have the automatic tool 0, where you actually don't have your like a tool holder for your machine, that it's going to reference itself, find the height of the tool, offset all that for you. But again, for that also, to be able to find the touch plate where you're going to come and reference your tool against, you need to know the location of that. So if you don't home your machine, how are you going to tell your machine that, hey, it's on my XY location there, go and do a touch off for the tool? So again, end of the day, when you're machining, it's all about references. You're machining to a certain location. So, homing becomes really, really important, because that's going to be the first step to give you the location of what you're doing. So, there's
a question here from Paul. I'm not sure if you can see it, Jet, asking about an XY in home point in Vetric Aspire. Yeah, there you go. Daniel's just answered that one.
Okay. Right, cool. And yeah, the CAM software is also let you put a home position, and basically what they're going to end up doing inside is probably put a G53 for you, and then you say, hey, that's my location where I want to go. So there are two ways. Exactly. You know, either you can do it manually, or you know, you can set up your CAM software in that sense that you set it once as per your machine, and then just use that, and it's going to have that reference point. But it's very important for you to also always keep in mind that where your machine goes as the homing position. And you know, the term homing can be either homing towards the sensor or to your predefined position. Keep that in mind when you're designing that part to what's your homing location for your reference. So I was talking about the tool spin. So yeah, for automatic tool zero, you need to do a touch off to be able to go to the tool setter or the touch plate. You need homing to be able to go to that point. Let's say if you're not using the automatic tool zero and you have the tool holders, then homing becomes even more important. And in that sense that you have the tools in your tool holder that you've calibrated either on the machine or with the height gauge. So those heights, those lengths of the tools, they are referenced from your Z0, and mostly your Z0 is you know, top of your Z-axis, the top travel. So if you haven't homed your machine, if you haven't homed your Z-axis, for example, in this case, your Z-axis does not know where it is. So if you have put in the values for calibrating your tools, you've calibrated 10 tools. From the controller point of view, it knows the length of each tool. It knows how much to offset. That's fine. But where to offset from? Because you don't have that set position. You have not homed your Z-axis, so you can't reference. So, you know, basically, with the tool changer, with the tool holder, if you don't have homing, you can't, you know, use your tool holders. It's as simple as that. So it's super important. So those were the points in my rough list. Ben, do you think, do you have anything that we need to cover, or we've covered everything so far with this?
No, I think you've mentioned everything that about wider home. Yeah.
Yep. Okay. Right. Great. So what would be the next? Should we talk about the switches and the sensors next, Ben?
And we just had a question on that. Somebody had asked Orlando, I think, what do you suggest besides using the lever switches?
Right. Okay.
Nothing wrong with the lever switches. They're cheap and easily replaceable when you smash them. But and some of them actually they're really what's the word? Look, almost authoritative. They bend, and they get to a point where they snap closed. So they're not airy-fairy about when they close, but they still have the issue of bouncing. They have the issue of the metal lever fatiguing over time and eventually
even
snapping. But if not,
temperature, because the metal changes properties with, you know, hot and cold big time. Yeah.
So yeah, they're a good option because they're cheap and easily found. But compared to the proximity switches and the opto sort of interference switches, they're probably not the best. The three types of switches that I've used are those lever switches, or the proximity switches that are, I don't know exactly how they work. I think they're setting up a magnetic flux and waiting for
inductive ones, I think, or the capacitive ones.
I'm pretty sure everyone's seen them though. They look like almost like a machine screw.
Yeah.
That's waiting for a piece of metal to pass it to interfere with its signal of some sort, and they appear to be more repeatable than the lever switches. I can't imagine they would be as repeatable as the switch with the infrared light waiting for you to interfere with it. I suspect that they are the best switch to use, and they're also the last two, the proximity and those. What's the name of those light switches, Jack? Do they have an official name?
They're called like slot sensors. So it's basically a slot, and then you pass something through. It's shooting a ray of light through it, and then, you know, as soon as that light gets stopped, you get a signal, and then you further have some electronics to actually filter that signal. Even with the, because when you're blocking that light, it does not happen instantaneously. You're still kind of,
well, it happens faster than anything else we can do.
yeah, it does. But if you really break it down into the whole electronics concept of it, if you see the graph, the voltage is going to drop. It does, very, very quickly, but still it drops. And then, if you don't have some sort of a filtration circuit, it might drop at a different, it might trigger at a different location. So having that electronics, it kind of makes sure that it always cut off on that level, and then you end up getting more repeatability.
The other two great things with those proximity and light switches are that they're not a dead stop where you have to hit a lever switch, and if you go too far, crush it, that lever switch. At least the interference, you can pass through it and not damage the switch.
Yeah, and another great thing that you can do is that's what we do in our machine setups, and that might give some ideas to other people. And you can actually do that with the proximity switches you were talking about, that actually mount them in a way that when you're homing, you can home at a faster speed. Okay, and then because just remember that when you're doing the homing cycle, you hit the switches or the sensor, it's not going to stop dead there, because if you stop there, you can lose steps or you can damage something. So we still have to ramp down the speed. It takes a while. So the faster you're going, the longer it's going to take for the axis to stop when you detect that homing sensor or the switch. So the way you should set it up is that if you have, sorry, let me switch the camera first. So much of my focus is going on the camera. So if you're homing against, for example, a setup like this, you're coming fast, and then you go through the sensor. But the only thing is you make sure that that little strip that is blocking that light does not kind of bypass the sensor, that, by the time you stop, it's gone through the sensor. So that strip has to be long enough that once it's stopped the light, it then is not triggered again, because the axis is going to stop slowly, ramp down, and then it's going to back off at a really slow speed till it finds that reference position. So you can still accurately home, but the only thing is that it's going to take more time for you to stop.
More time to stop, but if with that method, you could probably be homing at a higher speed.
High speed. So if you put the sensors maybe not exactly to the edge of your gantry, so it doesn't go and bang against the corner, because it will need some time to stop. So that's another consideration.
That'd be great though when you've got a full sheet size router table, for example, and you'd have the option of using a mechanical switch and homing at 600 or 800 millimeters a minute, or using that optical switch, maybe setting it up 150 mil from the end of the travel, and then really homing at a decent rate. And
the problem with that is the only problem is you lose that area for machining, because from the homing switch, that's going to reference your homing location.
Well, you could set your location.
I was going to say that. I was going to actually say that. Right? If it's, let's say, 500 millimeters of bed, you set it as 450. But again, if you come back, then it's going to, if your hard limits are switched on, then it's going to trigger as a hard limit. Right? But I think your idea of having two inputs. So let's say you have one at 450. And the axis is just going at full speed at 450. It knows that, okay, now I'm near the sensors. It slows down till it goes to that sensor. I think that's a much better idea. It's just maybe running another cable from the sensor to the masso. But I think for a bigger gantry where you want to save time on homing, that's definitely a good idea. I just want to talk about Orlando. That he put in this question about homing. He's a great guy. He's one of my clients from California. He makes wind turbines, and I really appreciate this guy. I think people should go and watch on his channel. This guy is working so hard, and I watch his videos, mate. He does electronics, mechanical. He just made a small lathe to machine parts for his wind turbines. Great guy. Every time I'm kind of feeling down, I've told him so many times. I'm like, I look forward to him. Great guy. Really great person. So so I think we've covered some points for them. I'm going to still go through those three sensor options again for your homing. So first one is switches, and the second one is light sensors. The third one is your kind of pickup sensors. They can be inductive or capacitive. The first one for the switches, they are they're cheap. You can get them from anywhere, but there are so many different types. If it's not good quality, it's going to be really bad. The good quality ones on high-end machines, the repeatability is really good. They use that on those. But you have to remember that these will change with time. Just simple things that they're going to wear off, or the contacts might build up some carbon. If it's really humid, it's been raining or something, over time those contacts are going to have carbon. Having carbon or not being able to connect properly is basically end up going to show up in your machine. So if you home to your, let's say, a certain location X0, that X value every time you home is going to change a bit. How much it's going to change is going to really depend how bad the switch is gone, but it can be 1-2 millimeters at times. So switches you have to select very carefully. Only good ones, I would say. The next one I said about those the light sensors. They are great. The repeatability is awesome. You don't have moving parts on those, so you can be using them day in, day out. In fact, when we made these sensors, we actually made it for a client. A lot of things just happen like that. Actually, people have an issue and they're like, hey, how do we fix it? They started using a mess on a production machine, and they actually have on a small lathe, they turn tractor parts, and they are now machining 1,200 parts a day on that machine. And you can imagine how important homing is on that machine, because you can waste a lot of times. Just try to rehome, re-reference to the same position, because they have the cut piece, they put that in the collet, cycle start, machine it, done. They had the switches, and when running production, the repeatability wasn't coming out. So that's where we said, okay, we're going to quickly design something for you. And it's been, I think, 1.5 years. They're running those two sensors that they bought. Never had an issue, mate. They run production 7 days a week, and any weather, any condition, they're working great. So those sensors are really great. But now let's also talk about where they can't be used. Those sensors, the way they're designed, because the light has to go through a little wall and hit the other side on the sensor, you can't really cover it. The electronics and the sensor is exposed. So things such as fluids, if you're have cutting fluids, you need to have the sensors mounted in a way that nothing gets into them, because if you have a cutting fluid or water or something going on the sensor, it's going to damage it. So that's one thing that you need to really watch, because otherwise they're great sensors, but on your machine, if you can't install them because of water or cutting fluids, then they're not probably good for that position. The last two sensors are really good, I would say, in both regards. In that sense, that repeatability is very good. On the repeatability side, and I've been trying to get feedback from clients, because there's so many different type of those sensors. The feedback that I've got is mostly good, and now either it depends on maybe the poorly designed sensors, because there's so many brands. There are so many good ones and bad ones of eBay and other stores. So I think it really depends on the sensor. So there are basically two different types. One is an inductive and one is a capacitive. They look exactly the same. The wiring is exactly the same. I don't have much information to say which one is better, but I think people are using more of those inductive ones. I was going through some data sheet for those sensors. They have some, because those sensors don't work by saying that, okay, I have something 4 millimeters away, exactly 4 millimeters away, and I'm going to trigger. I'm going to give you a signal. They work in a certain range. When you order them, it's like, hey, the trigger range is between 2 and 6 millimeters. 5 and 10 millimeters, whatever. So there is a certain range. And obviously when you're homing, most of the time it's going to pretty much trigger at the same point. But also, as per the data sheet, they said with temperature, it's going to change. So those are the things that you have to keep in mind. Those light ones, the temperature and those things, they don't make any difference. And they don't have a range because you are literally cutting a small beam of light. And, that light, because it's not, going in a certain range, it's focused onto the sensor. So you're just cutting that light. But these sensors are no moving parts, reliable. You can have water fluids on them, not a problem. They're fully sealed. So that's a good point. And in fact, people can give us some feedback in the chat. If they've been using a certain type of a sensor, maybe even the model number, because then it can help others. And share your experience that you've been using this, how repeatable they've been, how long they've been working for. But yeah, these are the 3 different basic types of sensors. Do we have any more questions, Ben, that I should be looking into right now?
I've only been watching a little lately. I think it's more just discussion between people that are watching at the moment, Jet. So
right. Okay. So okay. Let's move to the next bit then.
NONC wiring. It's an important one.
Yes.
About sensors.
Yeah. Do you want to start going with that one?
Yeah. Normally open and normally closed wiring. A lot of switches and sensors will give the option to have the sensor normally closed and only open when it detects a home, or normally open and will close the circuit when the switch is triggered. And generally,
so it's basically sorry, because we have a lot of people who are really starting into the CNC. So I'll just clarify a bit on that. Normally open or normally closed. Once it's very simple, but sometimes you see NONC and like, what's that? So basically, the NO is normally open. So if your sensor or switch is not triggered, you won't get any voltage. And if it's a NC, if it's not triggered, you will get voltage. As soon as it's triggered, it's pushed, the voltage will drop. It'll probably go to 0 volts. So that's the difference. With the NO, until it's triggered, you won't get any voltage. With the NC, it's inverted. So when you trigger, the voltage is going to go away. So yeah, Ben, I'll let you continue, mate.
Or the other way around, if you're pulling down to ground, or pulling up. But either way, yeah, the circuit is closed or it's open until the switch is hit. And it's probably more important for emergency stop switches than it is for homing switches, whether you go normally open or normally closed. But the reason to choose normally closed is that it's a little bit safer. When you're using a switch in a normally closed position, there is feedback to the masso or the controller. It's the circuit is always closed. It always knows that it always knows that the circuit's closed until you hit a switch and then something changes. And what that means is that the system always knows the switch is working.
And if you're running your machine and you don't know, the cable comes off, for example, you damage the switch. If it's a normally open system, until you go and try to home or try to press e-stop, you realize, something went wrong. It didn't stop. Yeah. So the
easy way to think about it is that a normally closed switch will always be saying, I'm working, I'm not. And the I'm not means, okay, we've hit a switch. Whereas the normally open is always saying nothing until it's supposed to say the switch is closed. And at that point, if the switch is broken, a wire's fallen off, some wires fatigued in the drag chain and broken, you won't know about it until the machine goes crash. Whereas at least using a normally closed switch, you'll know about it because your controller will tell you that it's hit a hard stop.
Exactly.
And you think, well, it hasn't hit a hard stop, the switch must have broken. And that's great because you get the opportunity to fix that now, not after the machine's crashed because a homing cycle failed.
Yeah. So from the actual usability wise, you can wire any type out of these to the controller. You can invert the logic on the inputs on the Maso. That's the easy option, but it's more of a safety thing that where it makes a difference. So yeah,
and ease of wiring. It is actually, if you're using multiple limit switches on an axis, so if you want, for example, your x-axis to have a limit switch on both sides, when you go to wire it, you have to you consider your wiring a bit more carefully when you're using normally closed.
Right.
It's usually a lot easier to wire normally open switches in series and in parallel than it is to wire two normally closed onto the same axis. So that's the other consideration, but really you're only doing it once. So
yeah. Cool. So yeah, I think that would cover up, and that's the case with any of the switches and sensors, because you can get models for sensors that are triggered in that sense, NONC. So you can select between them. All right. What's next in the list?
Types of wiring. That's another interesting one.
All right. So
we've talked about wiring up the switches or sensors in normally open or normally closed, but what type of wiring do you use for those switches? And I think the options are shielded or unshielded, really, and stranded or solid core cable. And I believe that shielded cables are great, and also that you should be using stranded when you're running these cables through a drag chain and they're going left, right, up, down all day. To have a stranded cable that's going to handle that fatigue a lot better without breaking, and it'll last a lot longer. And also having a shielded cable over an unshielded cable. Conveniently, the Maso has some pretty good filtering through the opto isolators on each input. So I haven't had any e-stop or limit switch issues on the Maso, but on other controllers that we've used and we still do use, the shielded cable really comes in handy, and it's only cents more per meter. So have you got any other reasons for using or not using shielded cable, Jet?
Yeah, no, mate, it's more, for us, it's more the actual physical life of the cable, because as you said, noise is generally not that big of an issue. It can be, let's say if it's a plasma system or something, definitely. But yeah, if you're building that CNC machine, putting a few more cents into your cabling with the shielded cable, it's always a good idea. And, I think that shielding also gives some physical protection to it too, But you're right. When you're running through those drag chains, having good cables is a good idea. It's just another way of stopping trouble later, kind of thing.
And most decent sized drag chains will have a fairly big bend radius of maybe 200 mil or 300 mil, and that really reduces the strain on the cable. So you notice if you were to take any cable really and just bend it in a really tight radius, you'll eventually fatigue it fairly quickly and snap all the internal copper threads. But using a decent sized drag chain that has at least 100 or 150 mil bend radius will also increase the life of all of the cables running through it.
Yeah.
I can see behind Jat there, the bend radius on that drag chain is probably 150 mil.
Yep.
And a cable should run in there for years, on a daily basis if it's a stranded cable. And I suppose the difference, maybe some people aren't aware that inside each core of say a 4-core cable, there can either be a single thick copper strand inside each insulator, or you might have 7 or 14 or 20 much smaller strands of copper making up each cable, and those stranded versions last a lot longer under constant movement. And you find, for example, with the computer networking, the Cat5 and Cat6 cable that runs through a building will be solid, and the little patch leads that are inside the electronics enclosures with all the, all the patching that's done under tight bend radiuses and things that are moved around quite frequently. They're all stranded cable for that reason, because the concern for snapping the conductors.
Right.
Mm.
Okay. Yep. No, that's a good point. All right. So I think so. Switches are covered, wiring is covered, and the last one would be let's list down those scenarios where you will need homing. So the first one is every time you home you power up your machine. That's the first place where you need to home to find the position. After that, as we said, if everything's running fine, you don't need to rehome the machine. You can just keep using the machine, keep remachining your parts, not a problem. But if you're running a machine and for whatever reason you hit e-stop, and that's where you need to rehome your machine again, because it really depends why you had to hit e-stop. It can be something wrong with the motor, with the drive, with something else, and at that point you might have lost steps. So, and it's not a guarantee. You could have not lost steps, but again, just to be sure, you need to rehome your machine. And again, in Meso, that's why we have that option to request for homing every time you press e-stop. So in the homing homing settings, you can take that. So every time you hit an e-stop, Meso will ask you to rehome the machine. The next one is alarms. So you're running your machine, you can run into alarms. So for example, it's a hard limit alarm. If it's a hard limit alarm, probably you've already, because you're not supposed to be beyond that travel range. So something had gone wrong, and you end up hitting the hard limit, and that's where you need to rehome your machine.
Definitely lost some steps at that point.
Yeah, that's why it happened actually.
The soft limits should have kicked in, and if they didn't, then obviously the machine's not where it thinks it is. And probably won't be restarting that job.
I remember,
anyway.
You were doing working on, I think, Michael's machine when the Z-axis coupling was loose or something, so it was always moving down or up a bit every time. So yeah, something like that. So definitely a mechanical issue. The other ones are drive alarms. For example, you have your drive alarms wired to the Meso. One of your drive faults out for whatever reason, overloaded, something wrong with the drive. It could be complete demotion, and something wrong with the encoder if it's a feedback type system. And in that case, again, you'll get an alarm on the screen. Meso is going to stop all the motion, and you go out and fix what was wrong, and then you need to rehome, because at that point you would have lost the reference anyways. Maybe not all 3 axes, but at least 1 axis. So that's where you need to rehome. Hard limits we've covered. Soft limits. Yeah, I think that would be it. What do you say, Ben?
I think that's homing. What about any of the guys listening in? Anyone got any comments on homing? Anything we've missed? Anything you do that we haven't discussed?
I have to go through the comments. I can see some comments from Larry. He wants to discuss about the frequency or the feed rates that you can generate with Meso. We'll probably have to cover this separately, but I'll just put a quick note here on how they're talking about 110 kilohertz and 40 kilohertz. As we've reported everyone that since we've been doing this upgrade with the new USB drivers and touchscreen, there is a bug with the USB drivers that's limiting the controller frequency to 40 kilohertz, and we will be fixing it back to 110. So this is more for the time being. And he's mentioned about the feed rates. Definitely on some machines, it's going to reduce the feed rate, the maximum feed rate. But a lot of other machines, because by the time you calculate your pulses per revolution and your pitch of your screw or your belt system, you can still get a decent feed rate with that. So, but yeah, we'll try to cover it in a future topic. And guys, send us an email. We can support you one-to-one with your questions too. Yeah. So what else? I'm just trying to go through the chat. Did we miss anything?
Bottom one here, the Sleepy Dogs has asked, what coordinates do we use for soft limits? And I use, I home to 0 and then work in a negative space. So whenever I'm out in my machine, I'm in minus 500, 500. And I'll set my soft limit for, on my particular machine, it's about 1300 mil. So I'll set for minus 1300, minus 1300 on my XY. And that's about 5 mil short of where the machine can physically go before crashing. And then I work towards 0 in the back right-hand corner. So yeah, I usually set my soft limits a couple of mil shorter than what the machine can actually run.
Yeah. No, that's the good idea. You always keep some room for it, and soft limits. And you know how we were talking about homing. Soft limits is very important. I would not tell anyone to sort of not use them. You can end up writing some wrong G code, for example, that can over travel rather than hitting and stopping.
Bad manual G code input.
Yeah, and I've done it myself too. Sometimes it's the same G code file you're trying to machine, but you overlook the work offset. Maybe the size of the job is small, 100 by 100 millimeters, and you're like, oh yeah, it's good, and then you overlook your work offsets or something else in the G code, and the actual motion is going to be maybe beyond your travel limits. And it's just another way, another safety thing. It just says, hey, what are you telling me to do? It's going to be beyond that limit, and not actually do that motion. And
simply said, actually, Sleepy Dogs just chimed in here again with asking about soft limits on the Z. And yeah, it's a little bit of a false security to use a soft limit on your Z, because your tool height's always different, your stock height is always different. And I personally, I've set the soft limit on my Z to 100 mil more than the machine's even capable of traveling, and I manage the Z axis myself, because I feel like to put a soft limit there or a hard limit on the bottom side of the Z axis would really be adding no safety and just making you feel a bit better about it. So because your tools are dynamic in that sense. The lengths are changing, your machine, your job setup is changing. You might have, like for example, when we are cutting one job and we put something underneath to not end up machining through the machine bed or something, then you're basically changing that height reference. And definitely at that point, it will be not that useful. But again, at least going up, a lot of times, when you're going up, you can give a wrong G code and you can end up hitting something on the top. So it's, for sure, like, it's a good idea to have that. For plasma machines, if you have torch height control and the Z on that is really useful then. For whatever reason, your Z says, hey, keep on going up, or going down. And again, it's going to still have that thing that, hey, my job thickness was this much on the Z axis, on the machine, and the torch end up hitting the machine. It will be there, but at least there's going to be some safety to it, saying that, okay, it's just telling me to go beyond that limit, because the Z height control in automatic torch control is dynamic. You're not using any G code. It's getting the feedback from a third system to know the Z position, and it can change, and have the soft limits will really help. Oh, right. Yeah. So you would set a soft limit on Z for that, for sure.
Yeah, because concept-wise, you're still running the same platform underneath for a plasma system, and we still use the soft limits for the Z-axis, just like any other system. If you try to go beyond that limit, it just won't do it. Actually, what it does, that it actually ignores that. If you say, hey, go up, and you've reached the soft limit, it won't move. Won't move.
So I suppose you could set a soft limit on any machine though, and you could set that so that the carriage doesn't bottom out or fall off the end of the screw. But chances are your tool is going to hit something before the machine crashes on a Z movement. So yeah, I suppose it is a good idea to still set your Z soft limits just to the point where your Z carriage can't go any further, but don't rely on them, because chances are there's a tool or a piece of stock that's going to crash before. Unless you're using a plasma.
And at times, I think it's been 6-8 months. We had a thought when we actually added the automatic tool 0. We said, okay, we have automatic tool 0, and we can use that reference, and we know that where the tool is, and have kind of a dynamic soft limit that every time you do a touch off, it updates itself that, hey, okay, now with this tool, this is my limit. The problem with that is then you don't know where your job is.
Yeah, stock and fixtures, they're still there,
so
and unless you model them in, which is, I know you're supposed to do, but I never do it.
But simply the way I would set up on the machine for the X and the Y axis, at least when I've loaded up the job on the screen, and as you're moving, you go to the jog screen and you move your X and Y axis once you've offset your job and everything, and visually you can see the cursor on the screen. And I generally go on all 4 corners of the job, and then that way I can see where my machine is going to actually machine this job visually. With the Z-axis, because it's not an isometric view, it's just a top view, you have to kind of visualize when you're designing your G-code, but it gives you a very good reference point. And especially if you're doing a quick machining job, maybe you're engraving something on a piece of wood or something, and you can just go and reference yourself. So visually,
watch out for your G28s though. You can check the corners of that.
It is
G20. Still have it whizzing off.
Yes, exactly. G28 is that's why I mentioned it. It's one single G code that you say, okay, that's fine, and because when you're making toolpaths, you are telling the system to make those toolpaths. You're concentrating on that. The system makes all those toolpaths. That's fine, Fusion or any other CAM software. But if you have the G28 option tagged in, you kind of overlook, because in some post processes, it's by default switched on. And then when you run your G code, you're like, where did that came from? I never tell it to do G28 for me. So always check the first 4 or 5 lines of your G code anyways, before you run it, and you make sure the location is right.
Actually, that brings me to another thing I'm going to put on my Masso wish list: the some kind of regular expression exclusion for lines of G code. It'd be great if I could go into a setup screen somewhere and put in a G28, and the Masso would always know in the future to ignore it. And
right.
I'll just put that on the list. I've got a big list of things to keep Jap busy for the next 12 months, and little features that I'd love.
We can do something in regards to, every time you open a file on Masso, it takes a while to process the file. The reason for that is we're trying to understand the whole file, the limits, or how much it's going to machine, and try to visualize on the screen. And as some of you might know, that about 2 weeks ago, we released a new software update where you can actually resume your job. If you were cutting something and you can actually jump back to the same line, it's going to process everything back till that point. So if you were running a file that was 20,000 lines of code, you run it to 5,000, something happens, you have a power failure or something, you can load that same G-code file, and Masso will remember the last line number where you were running that file. And then you put that same line number, it's actually already filled for you. You load that same file and you say, hey, I want to start my program from this line. And generally you start a few lines before that. And what Masso is going to do is that from line 0 to, let's say, line 5,000, it's going to process all that information in its memory. So, what your spindle was running at, your tool you were using, the location, all those things.
Coolant state, all that.
Yeah, exactly. And then go back to that location and start machining. What we can do is that have something what you said, Ben, that maybe when you load a file, it actually gives a bit of description. It opens a little window on the screen and it says, hey, by the way, I'm going to machine this job. The left limit is going to be this. The right limit is going to be that. The height's going to be this. I'm going to use G28. I'll be switching on your pump. I'll be running your spindle. So you can quickly go through that and say, okay, yeah, that's fine, and something like G28, and maybe it can be highlighted in red just for you to know, hey, there is a G28. Make sure you see that. And over time, and if something else needs to be added, we can just add that to the logic and set as a little marker telling the user, hey, mate, we have this in your G code. Just double check that you intend to use it. If you do, yeah, it's all good. So, all right, mate. I think time's good. I was, again, I don't know why. I'm always stressed out with timing. I think that we won't have much to talk, but I think we always have a lot. I think we were able to cover pretty much everything. I'll just quickly go through the chat. Ben, do you have something else to say till then?
No, there's another note here from Larry, the last post there. Does it have to be line numbered for the Masada Roomba? I suggest not. Is that the case?
Yeah, you don't need to have the line numbers. No, we designed it. It's actually the line number, the physical line number in the file. So if you have the same file, let's say open in Notepad on your computer, and you scroll through and you say, hey, I'm on line number 10. So it's that line number. In the future update, we will be also working on the N number. You know how you have in the G codes the N number? So it will actually give you an option for both. It will say, do you want to jump to the N number or the actual line number? The reason for the line number is because initially the biggest thing was when you're running this file and somehow your machine is switched off, power failure or something, gets damaged or something, you're not standing in front of the machine and looking at the line number you were running at. So we had to save that in a memory on very high speed, that as it's cutting, it's saving that in the memory. So that's why we reference back to the physical line number of the file. And you can, just use that line number to jump back.
A bit further back, Paul Connolly was asking about his XY position from Vectric Aspire, and is asking if you can use that as the Masso can use that as a homing point. And no, I don't think so. I think that is a reference for that job, and in Aspire you may have to offset that from home or use some kind of work offset. The only way for the Masso to use that XY position you've set up in Vectric would be if you were to move to the corner of your stock and do a Control X, Control Y, and reset your zero position there.
Yeah, and also, it's not a must to zero your machine before, like when I say zero, to move to a certain location, homing or whatever, before you start a job or when you end a job. It really depends on you. Most of the times, I personally don't even prefer it, because then I know what I'm, where my machine cycle is going to be, and then once I'm done with the job, I can just move my axis away from it, at a comfortable position. The other point was when you're making your G code file and your location of the job, you can offset in your CAM software also. But I think the right way is that you actually produce your G code from the X, Y, Z, maybe Z also 0, but yeah, at least X and Y 0, because that way, when you're setting it up on the machine, you can use the work offset. And that's the whole idea of work offsets. If, let's say, you were running the job at 100 by 100, X100 and Y100 location, and now for whatever reason, you can't put the same material back at the same location, and it has to move to, let's say, 150 by 150 location. Then you go back to your CAM software. You can still use work offsets, but it's going to get a bit more confusing, because then you're in your head, you're calculating that 100 reference and then work offset. If it was at 0 location, let's say your X and Y 0, when you made that G code file, then referencing it to, let's say, X100, X150, it becomes really easy. Less confusion. So export your files from reference point 0, and then use the work offsets on the machine to run that file. Another benefit is if you were to give that file to, let's say, someone else. I don't know how often that happens, but let's say if I have to give Ben to machine something, that reference 0 means that whatever size his machine is, he can still use that on his machine without causing much confusion.
Yeah, yeah, and I actually do get a fair bit of G code from people who are having an issue and need me to do a dry run on my machine, and that's actually the reason why I was saying I'd like to be able to avoid a G28, because I have them turned off, but I quite often get G code from somebody else with it all on. But yeah, no, that's a good point. If you're going to share your design for other people to machine without having to go through the CAM themselves, which generally doesn't work because every machine and every user has a different need for feed and speed. But if you are going to share it, at least for support, then using your work offsets is very handy.
Yep. No, that's a good point for G20. That's a classic. Actually, I never thought in that way that you end up getting those G code files, and yeah, you're right. You can watch your own code, but you get something from someone else, and generally you're busy. I'm saying it like look for the first 4 lines, but even we miss out. Yeah, mate. All good. So Ben, I think we've been able to cover up pretty much everything from the list. Again, if there is something that you guys think that we've missed up, or you need some more information, let's say about Jaime, we can cover that a bit in the next week's topic. If it's going to be a lot of things that we need to cover up, we can do another video for Jaime, let's say. Sorry, not next week. My bad. We're doing these podcasts every 2 weeks at this stage. But for the next session, we can do that. And any other topics you guys want to talk about, please send emails and give some input on what topics. It can be any. If you want to know how to use a feature, if you want to talk about adding a new feature that's going to make everyone's life easy, it can be anything. And yeah, just keep your feedback coming in. That's how we're designing all these programs. Whatever you guys are telling us, we just pick up a topic that's kind of in the most need, and yeah, talk over it. So all good. And yeah, anything else, Ben?
No.
All right, great, mate. All right, cool. So we'll just wrap up again. And thank you, Ben. Hopefully you can get some rest over the weekend, mate.
Will do. Thanks for having me again, Jet.
Yeah. Always good to have your input on this. And yeah, a lot of learning for me. G28, the biggest one for me for today. So, all right, guys. Thank you, everyone. And hope everyone had a good time. And talk to you soon. Bye.
Good on you. Bye, guys.